Hi there, I'm Nick, and welcome to this video. I'm going to go through the basics of using the new JavaScript client to interact with the Solana blockchain. Specifically, we're going to go through using Gill, that's G-I-L-L. This is one variation of the new JavaScript clients that exist. It is fully compatible with Solana web3 JS or Solana Kit from Anza. It uses the same libraries under the hood, but let's go ahead and dive in. So you can see here on the README for Gill itself under the Solana Foundation's GitHub org, we have a fairly detailed README that describes a lot of the stuff we're going to go through in this video, but I'm just going to go through and explain everything. We're going to do the coding, and it's going to be awesome. So take a look at the README, and let's go ahead and dive into some code. So to start us out here, I have a very basic TypeScript Node.js repo sort of scaffolded out. The only thing that's in here right now is these dependencies, basically to use TypeScript and Node, as well as loading environment variables if you so choose to. And then we're actually just gonna code everything directly right now. So the first thing to do is actually installing Gill. Now I am actually gonna use pnpm as my package manager, but I'm gonna go ahead and install Gill. So pnpm add Gill. And it's gonna install my node modules, give me full TypeScript support, and now I have Gill version 0.2.0. At the time of this recording, this is the latest version. I actually just published this version yesterday. So it's still in beta, but it has a lot of additional functionality on top of Solana Kit and Solana web3 JS version 2, but still being compatible with it. So let's go ahead and dive into some code. The first thing that you're gonna wanna do when you're interacting with a lot of these things, especially if you're doing basic scripting like this, is you need some sort of key pair to actually sign transactions. So in my case, I'm actually going to be loading my local key pair on my file system. So I'm going to load in this nic6z address, and Gill has this amazing helper function to actually help you load key pairs in from your file system. So I'm going to create this signer. I'm going to call it signer, and I'm going to load it in using the load key pair from file. Keypair signer from file. There's two different types of key pairs that exist within the new JavaScript client. There's a key pair and a keypair signer. A key pair under the hood is just the web API crypto key pair from the standard crypto libraries. And then a keypair signer is one signer that is specific to using and interacting with the Solana blockchain using the new JavaScript client. It gives you some of the ED25519 cryptographic stuff built in, and it makes it so you can easily sign transactions and messages that are all compatible with the Solana blockchain. So now that we have our signer loaded in, it's actually just that easy to load a key pair from your file system. Specifically, this will actually load the default key pair from the Solana CLI, or if you want to pass in a specific file path in here as the value, you can also pass that in too. But since I just want my key pair from my file system using my local Solana CLI key pair, I'll go ahead and log this out to show you that it is in fact the same. So once you have a key pair signer, I'm just gonna keep calling them signers for short, you can call the address or the key pair. You can see it is a crypto key pair there. It also has a sign messages function and sign transactions, and we'll get to that later. So now that we actually have the signer, we can go ahead and log this out, and we can actually run all the scripts within this repo using esrun. If you're not familiar with esrun, it's this phenomenal lightweight JavaScript runner package that you can basically throw any JavaScript, TypeScript, CommonJS, ESM file at it, and it will just handle everything. It'll work no matter what. It's awesome. So you can always run npx esrun and then just pass it the file name. In this case, it's the script.ts. And you can see here that I did in fact load this exact same signer from my file system. And now the reason I'm doing this is because when you're interacting with the Solana blockchain, if you're using one of the public networks, you need Sol in it. In this case, I have devnet Sol on this particular wallet. I am connected to the Solana devnet here in my Solana CLI. So I have devnet Sol, but if you wanted to connect to any other network, you can also do that. Speaking of which, actually connecting to the Solana network with the new JavaScript client, you can create a Solana client connection, getting access to your RPC methods and all of those things using the create Solana client function from the Gill SDK. And within this, you can actually pass in the URL or the moniker for any of the networks. If you wanted mainnet or if you wanted devnet, you can pass in the actual string for them. And you will get a devnet RPC connection here. So you can see if you hover over it, we have our RPC devnet, and this has access to all of the Solana RPC API calls, so the RPC methods. And we can actually now just call these RPC methods directly within our code. So let's go ahead and do that. One of the most common RPC method calls that you're gonna be using a lot is get latest block hash. Because the way that the Solana blockchain works, you need the latest block hash to include within your transaction. It's basically like a recent timestamp check that your code can actually submit with your transaction. So we need to actually get that from the blockchain. So in order to make RPC calls, we can call the RPC, use our RPC connection here, and you can see within our editor, we get auto completion within IntelliSense, and we can get the latest block hash. And then when you actually are ready to send this RPC call to your RPC server, in this case, we're using the public devnet endpoint, you call the .send function. And then if you want any custom configuration information in here, like an abort signal using JavaScript's abort signals, you can do that too. And since this is an async function, we can also get this value. To note, most of the things within the new JavaScript client does use async await, so you'll have to use promises and all that kind of stuff within JavaScript. Most devs are familiar with this at this point, but just to point that out. Once you get the response back from the blockchain itself, from your RPC connection, this is a pretty common syntax that you'll see in a lot of the examples. Because the way that these RPC methods work under the hood within the new JavaScript client, you actually just get a generic value key back, and this has the value that's actually returned. So using this JavaScript syntax, you can basically rename this value attribute to be called latest block hash, or whatever attribute name you want to give it. So now our latest block hash is actually stored within this latest block hash variable. And just to show it out, we'll go ahead and log this. And if we go ahead and rerun our same script, you can see we've got our latest block hash directly from the blockchain. If I run this again, we'll get a different value. We can see our last valid block height has ticked up, and the blockchain is progressing along. So that's how to get a block hash. That's how to make any of the RPC calls to the blockchain itself. The next thing is actually creating transactions. The easiest way to create a transaction with the new client is actually using the create transaction function. Kind of makes sense. So we'll create a transaction. I'll call it TX, and I'll call the create, if I could type, create transaction. So we're going to call create transaction from the Gill SDK. And this takes in an object that wants all of these values, basically. So there's, notice how there's a question mark here. These are optional values that can be included within your transaction. Ultimately, these are highly recommended to be included. Latest block hash is ultimately required when you send your transaction, but let's go ahead and fill in this information. So the fee payer for this transaction is going to be my signer address. I'm going to pass in some instructions. We haven't created those yet, so I'm just going to give this an empty array. Next up is I'm going to give it a version. I'm not doing any address lookup tables here, so we're going to go ahead and make this a legacy transaction. I'll go ahead and reorder those. And now we have a valid transaction that we can continue processing, continue doing things on within our code, and ultimately send it to the blockchain. But our transaction doesn't do anything yet. We didn't give it any instructions. So let's go ahead and create our very first instruction. So the way that instructions work within the new JavaScript client is similar to how they work with web3.js version 1. You still have the same information under the hood, but the way you actually create those transactions might look a little bit different. So within Gill, you can use any of the system program, the compute budget program, token 22, and the memo program. All of those are included within the Gill package. So if you install this one package, you get a single entry point to all of these compatible clients. So let's go ahead and create a simple instruction. This will be our memo instruction. This is sort of the simplest instruction you can possibly create on the Solana blockchain. And we can actually import the get add memo instruction function that's exported from Gill. And we can basically just give this just a plain memo string that we want to send to the chain. And we'll say GM world. And now we can just include this single transaction within we can include this single instruction within our transaction. And then we're almost ready to send this to the network. Let's go ahead and log this out just to show you what the structure of this transaction actually looks like. And we'll go ahead and rerun the same code. I'll go ahead and clear my terminal, rerun the same script, full screen this. And you can see we have, again, the same signer being loaded in. We have this transaction object. We have our latest blockhash again. We'll ignore that for now. And our transaction object, we have our instructions, which is an array of instructions. We're interacting with the SPL memo program. We're giving it some data. This is automatically handled under the hood when you create instructions using these types of helper functions. It will properly format all the data that's required for that transaction. It does the proper encoding. It converts whatever input you put in there to a raw uint8 array, which can be sent over the wire. We have our transaction version. This can be legacy or version 1. We chose legacy. And then we have our fee payer information. And you can notice here that this fee payer, it's the same address. And we have our key pair, our signed message, and our signed transactions, because this fee payer, how we created it within this transaction, is a full signer. It has the ability to actually sign this transaction. Sometimes you might fall in the case where you just have an address because maybe you want your users, your customers, to be signing the transaction, paying the transaction fee. You can pass in the address itself. So if you just have the base 58 address, you can pass that in. And if you rerun this, you can see we have the address set as our fee payer, but it doesn't have any signing capabilities. So if you have a front-end application where users are connecting their wallet, Phantom, Backpack, Soulflare, whatever, they can then sign this transaction. They are the fee payer, and then you can send it to the network that way. But because we are going to be the signer here, we'll go back to this. And then the last thing we actually need to send this transaction is the latest block hash. So I'll go ahead and reorder this. And we'll go ahead and include our latest block hash inside of this transaction. And now our transaction is fully ready to be sent to the blockchain. So now that we actually have our transaction, we need to be able to send it to the blockchain. So how do we actually do that? Well, first of all, we need to sign the transaction, and then we can actually send it to the blockchain. So we can sign the transaction using, again, one of the functions that are within the Gill SDK and also within Web3.js version 2 or Solana Kit. I'm going to create a new variable called sign transaction. So we're going to go ahead and grab the function we need here, which is called sign transaction message with signer. There we go. I'm still learning all the new names myself too. And all we do with this is it's, again, an async function. So we need to await the promise, and we can pass it our transaction. And now we have a signed transaction. So let's go ahead and log this signed transaction out as well. We'll go ahead and rerun the script, and you can see our transaction from before it's signed looks exactly the same as before. Our fee payer has the ability to sign this transaction because it has signed transaction function. And our signed transaction actually looks different, because what this signed transaction actually is, it's all the message bytes and the actual signatures from our address, from our wallet, our signer, and our lifetime constraint, so our recent block hash. It's included all of this, so this is fully serialized, ready to send over the wire. So now that it's signed, we can actually send it to the blockchain. So how do we actually send a transaction to the blockchain? Once we have it signed, well, we call send and confirm. So within the create Solana client function, it will not only return our RPC connection, but there's also the send and confirm transaction function, which we can, like you guessed it, we can await the promise for it, give it our signed transaction, and now we have our transaction. We can send it to the network, and it's done. It's done. It's there. Our transaction will land, go through all the good stuff. Yay, blockchain. But what's our transaction signature? Like, how do we get that? There's a function for that. Once a transaction is actually signed, you can actually get the signature directly out of it. So we'll say this. Let sig equals get signature from transaction. We'll give it our signed transaction. And we'll go ahead and log out our signed transaction, or rather our transaction signature. And if we go ahead and run this transaction, or run the script again, you can see the editor looks kind of like it hangs a little bit, because it's actually sending the network request, and we have a transaction signature. Well, the cool thing about the Gill SDK is not only can you get the transaction signature before the transaction's actually sent because it's been signed once, that's just how Solana signatures work, but the send and confirm transaction function also returns the same signature. So we can also log it out a second time if we want. And if we resend the transaction, you can see that the transaction signature is the same on both because that's just how Solana transaction signatures work. Now, once you have a transaction signature, you might want to inspect this on the Explorer. Well, there's, you guessed it, a function for that. Inside of Gill, there is a get explorer link function, and you can get the Explorer link for an address, a block, or a transaction. So since we already have our transaction signature, we can go ahead and say, this is our transaction signature, give us the full Explorer link. Now, by default, this function will give you the mainnet Explorer link, but if you look up here, we're actually connected to devnet. So I'm actually going to create a constant, Solana cluster moniker, and I'm going to call it devnet. And I'll go ahead and replace this in here. And then inside of get Explorer link, we can also pass in the cluster itself, and then get Explorer link will get us the correct Solana Explorer link, so explorer.solana.com, for whatever cluster you want. So mainnet, devnet, testnet, or even localhost. So if you are interacting on localhost using a local test validator, you can also use the Solana Explorer to view all that too. So we'll go ahead and log this out. Run the script again. You can see we now have this Explorer URL. It has the cluster devnet. So let's go ahead and open this. So if we pop over to the Explorer now, same URL that's loaded up, here's our same transaction signature. You can see all the typical Blockchain Explorer stuff. You can see we're connected to devnet over here. And if you look at the transaction information itself, we have our accounts, that Nick6Z, that was our signer, was the fee payer, signer, and writable. It has the memo program, and we have our single memo program instruction. It's there. We have our good old-fashioned GM world put inside the memo, and now GM world is on-chain on devnet. But there's something you might notice about this transaction, and it's the fact that we don't have any priority fee or compute budget information already set for this transaction. We consumed some compute units, so we consumed about 4,200, almost 4,300. And the best way you can actually have success in landing your transactions on Solana is by setting your priority fee and setting your compute budget settings via these instructions within your transaction itself. And that's absolutely the best way you can get your transactions to be landing faster and landing more reliable. So how do you actually do that? Well, you have to add 2 instructions to your transaction itself. You could go through the process of manually adding them, manually crafting these, but with the create transaction function, you also, if we hover over it, well, kind of gives us the ellipsis. With the create transaction function, you can actually easily set these values, our compute unit limit and our compute unit price. So let's go ahead and set a compute unit limit. So we can go ahead and give it a value here. So our previous value was about 4,200. Sometimes you need to add an additional buffer on top of the compute units consumed. So we'll just go with 5,000, and we'll go ahead and run this again. You can see our transaction goes through, new signature. We'll pop back over to the Explorer. You can see we consumed a different amount this time, about 4,400. And you can see this transaction is actively being confirmed because this blockchain is actually that fast. So there we go. Now it's been finalized, reached maximum commitment level. And now we have an additional instruction within here. We set 5,000 CUs as our budget limit for this transaction. And that's it. It's that simple. You could do the exact same thing with your priority fees. So if you have a priority fee value, you can also set that here, our compute unit price. That's part of your priority fee. This is basically you set micro units per LAN port. So if we say, micro LAN ports per compute unit consumed. So if we are saying we're going to consume 5,000 as our maximum for this transaction, if we say we're going to pay 1,000 micro LAN ports per compute unit, we can send this transaction again. You can see we have a new Explorer link. Go ahead and open this up. Swap back over to the Explorer. Transactions being confirmed. We have, again, our value has changed here because we're doing more computation. We have the compute budget instructions. Now we have our compute unit limit, our compute unit price. we have fully set and fully optimized our transaction by including both of these instructions inside of it. So the last thing I want to show within the Gill SDK is debug mode. This is this nifty little feature that we put inside of the new JavaScript client here, and you can basically enable debug mode to help you as a developer debug your application, debug your transactions. So you can enable it in 3 different ways by setting the Gill_debug environment variable. So if you have, you're using a serverless function or Vercel or, AWS, GCP, whatever, you can set an environment variable or even, node locally or bun locally, whatever. You can set this environment variable directly through your CI/CD and things like that. So if you have like your preview environment, you can enable debug mode within that preview staging environment. You can also set the global value or in window using the window object. So in your browser's console. So if you have a front-end application that's deployed, you're testing the actual application. Even if you're testing it on localhost, you or any of your users, so if you have an advanced user, they can enable debug mode within their console, so that way they can get some of this information because it's all public blockchain information anyway. And this can really, really help debugging applications on the front end. So we'll go ahead and enable debug mode here, and we'll turn on, we'll set this global environment variable within our code. And we'll go ahead and set this towards the top. It doesn't really matter where you set it, as long as you set it towards the top. Actually, if your editor is configured to support TypeScript, so we can actually see that we have this Gill debug level and Gill debug mode, or Gill debug values. We can set these, we can set our desired debug level if we want. We'll enable debug mode by default globally for this entire script. If we run this again, go ahead and clear, we'll run the script again. And you can notice that in some places in the code, I think in this one, we just have this one example, we are enabling info debug mode by default. That's the default log level. And you'll see that you'll get these Gill prefixed console logs just sprinkled throughout your code. This can really help with debugging. Right now, this one we just showed the transaction URL, sort of not as helpful because we're already doing that within our code. But this can make it so you don't have to sprinkle console logs throughout your code. You can just turn on debug mode or turn off debug mode. The other one here is actually controlling your debug log level. So if we change this to include debug level of debug, the lowest level that is supported within the Gill SDK, we can run this script again, and we'll see how the output actually changes. Now there's 2 logs. We have the same one as before, because this is info. Info is sort of above debug. So if we enable debug, we'll see all the debug logs. And we also get the base64 transaction logged out for you as the developer, or maybe your front-end dev, or your users if they really want to. They can get the base64 transaction here. And the really cool thing about this is that you can copy this base64 value. You can go to the Solana Explorer, switch back over to here, click on this inspector tab at the top. We can use the transaction inspector. We can paste in our base64 transaction, and then we can just inspect this transaction, whether or not we sent it to the network. So maybe you have some sort of issue where your transactions are not landing, they're all failing, you can't figure it out. You can pull it up on the inspector here and view it like it's a block explorer, like it's a live transaction that actually went. You can simulate it, get all of our transaction outputs. You can check all the values. Oh, went back by accident. Simulate it, and you can see all the exact same information that you would expect to see on the Explorer for a transaction that actually was valid and sent to the network. And this is really cool. So if you have any error logs that you want to, or error messages that you're trying to debug, so let's say if we set our compute unit limit to a really low value, and we try to send this again, you can see, oh no, our transaction failed. For one, we have the logs that are displayed here just because we have this whole error message. But if you copy and paste this base64 transaction, go back over to the Explorer, and go back to the inspector, paste this in, you can see same information. Transaction appears to be valid, but if we simulate it, we can see sort of the pretty log output for trying to figure out what actually happened within the transaction. So this is a really, really nice troubleshooting tool that Gill ships with. So that's going to wrap it up for this video. I hope this was really helpful, giving you sort of a really quick crash course on the new Solana JavaScript client. or I guess the new JavaScript client for interacting with the Solana blockchain. Thanks. Catch you in the next one.